Hey guys, today we're going to be talking about graphing parabolas. The formal definition for a parabola is the set of all points equidistant from a focus to a directrix. So what that means in this picture is every point on the parabola is the same distance from the focal point. So this distance is the same as the distance from the point on parabola to the directrix. So those two distances are equal. And the same can be said for every point on that parabola. So the distance from this point on the parabola to the focus is the same distance from this point on the parabola to the directrix. The same distance from this point on the parabola to the focus is the same as this point on the parabola to the directrix, and etc. So you've graphed parabolas before. It's just that every time that you've graphed them, when you graphed them in Algebra 1 and Algebra 2 and so on, your parabolas could always have been written in the form ax squared plus bx plus c. And those parabolas all either opened up or they opened down. What we're going to look at today is graphing parabolas that have a y squared in them as opposed to an x squared. So when you have a y squared parabola instead of an x squared parabola, those parabolas are going to open either left or right depending on what's going on in that equation. Each of these little pieces in the formulas that we have here, so x minus h squared equals 4p times y minus k. If I look at that equation, if I pull out h and k, that's going to give me the vertex of my parabola. P is the distance from the vertex to the focus. So the different distance from the vertex to the focus. And the directrix is always going to be y equals k minus p. So you'll see our goal is going to be to get the equation to look like this in order to be able to pull out h, k, and p. The same is going to apply for a y squared parabola. So for these parabolas, I have y minus k squared equals 4p times x minus h. hk is still the vertex of the parabola, and p still represents the distance from the vertex to the focus. The difference, however, is how we find the focus and the directrix. So the focus for a y squared is h plus pk, and the directrix is an x equals line of h minus p. So again, for the y squared ones, our goal is going to be to get the equation to look like this in order to be able to pull out h, k, and p so that we can find the focus and directrix and then graph from there. Let's do an example. So in number 1, I have x plus 1 squared equals negative 8y minus 3. Now, this is already in one of these forms, so I don't have to worry about trying to get it to look like that. I have an x plus 1 squared, so I know it matches this equation. So I'm actually just going to rewrite this down here. So x minus h squared equals 4p times y minus k. I can see that the h matches up with the 1, and signs are opposite. So my vertex is going to be negative 1, positive 3. And again, that's coming from h and k up here. Next, I'm going to want to figure out my p-value. So in my equation, I have the negative 8 matches up with 4p, which means I can say that negative 8 is equal to 4p, and I can solve for p by dividing by 4, and I get negative 2. Once I have p, that will now allow me to find the focus and the directrix. So I'm going to start with the focus. For the focus, my formula is h, comma, k plus p. So h we just figured out was negative 1, k we just figured out was 3, and I'm going to add p. So I add a negative 2. So that means that my focus is negative 1, comma, 3 plus a negative 2 is a positive 1. The last thing I need to find is the directrix. So the directrix is y equals k minus p. We just figured out that k was 3 and p is negative 2. So minus a negative 2. That becomes plus a positive. So y equals 5 is my directrix. Once I have all this information, I'm going to start graphing. I'm first going to graph the vertex, the focus, and the directrix, and then we'll go from there. Now I have my directrix, my vertex, and my focus. My vertex is always going to be between the directrix and the focus. From here, I'm going to use the focus to find 2 more points on my graph. If I look up here, I can see that the focus is midway between 2 points directly to the sides of the focus. I also know that 4p represents the focal diameter of the parabola, which if I look at the focus, this whole distance across is considered the diameter. So in this example, I know that -8, that 4p, -8, is the focal diameter. So if I cut that in half, I get 4, which means from the focal point, if I go 4 units to the right, plot a point, 4 units to the left, plot a point, that's going to be my extra 2 points that I need to then graph my parabola. There are my extra 2 points, and now I'm just going to graph from the vertex through the point, make a parabola, from the vertex through the point, and there's my parabola. Number 2, consider the equation y squared plus 4y plus 8x equals 4. Put this equation into standard form and identify the vertex, focus, directrix, and graph. So the first thing I notice here is that this is obviously not in standard form like number 1 is. So I'm going to have to get it in that x minus h squared form or the y minus k squared form. The question is which one? The way I figure that out is by looking at which variable is being squared. So in this equation, I see that the y is the variable that's being squared, which tells me that I need to get this equation in that y squared form. So I'm going to need to get this to look like y minus k squared equals 4p times x minus h. What I'm going to do in order to do that is get all of my y variables on one side of the equal sign and get everything else on the other side of the equal sign. So I'm going to leave the y squared plus 4y on the left side. I'm going to subtract the 8x over and leave the plus 4 on the right-hand side. What I'm going to do next is complete the square for this left side with my y variables so that I can then write it in this form as a binomial squared. So in order to complete the square, I do y squared plus 4y plus blank. That's going to help me complete the square. But I have to keep my equation balanced. So whatever I add onto one side, I also need to add on to the other side. In order to figure out this value that I need to complete the square, I look at the number in front of what would be the b term in an ax squared plus bx plus c standard parabola. I look at that b term and I half it and square it. 4 divided by 2 is 2. 2 squared is 4. So I'm adding 4 onto both sides. I'm now going to rewrite this left side as something squared. That's going to be y plus 2 squared. And on the right side, I'm just going to clean up. So that's going to become negative 8x plus 8. I'm close to this form now. My left side matches up. But for the right side, I need to pull out this GCF of 8 so that I have y plus 2 squared equals negative 8 times x minus 1. Now my forms match up. From here, I can use the formulas we had on that first page to figure out my vertex, my focus, and the directrix. So I'm going to start with the vertex. The vertex is hk. H comes from here. K comes from over here. So my vertex in this case is going to be positive 1, negative 2. The signs are opposite. The focus for this parabola is h plus p, comma, k. I found k. I found h. I don't know what p is yet, so I need to figure that out. I know that 4p is going to be equal to negative 8. So when I set those equal to each other and divide, I get p is negative 2. So now I can use that to help me find the focus. So for the focus, I have h plus p. H was 1. P was negative 2, comma, k was negative 2. So that means the focus of this parabola is 1 minus 2, that's negative 1, comma, negative 2. The last thing that I need to find is the directrix. The directrix for this equation is x equals h minus p. We found that h was 1. We found that p was negative 2. So that means my directrix is positive 3. So now I'm going to go ahead and graph my vertex, my focus, and my directrix, and then I'll go from there. Okay, so here is my directrix, my vertex, and my focus. The vertex, again, is always between the directrix and the focus, and now I can see my parabola is going to open up this way towards the left. Using the focus and the focal diameter of 8, if I divide that focal diameter by 2, I get 4, which means I need to go 4 units away from the focus in either direction to get my other 2 points that I need to help me graph this parabola. Once I have those 2 points plotted, I just need to connect through. For 3 and 4, we're going to sketch the graph of the given parabola, and we're going to find the vertex, focus, and directrix. So in number 3, I have x minus 3 squared is equal to negative 16y. Since this is an x squared parabola, I know I need the standard form of x minus h squared equals 4p times y minus k. I'm actually going to rewrite that right side so it matches up a little bit. I'm going to write that as negative 16 times y plus 0. That way I actually have a k value, which I didn't have up here. So when I look now, I can see that this is going to be my h value and this is going to be my k value, which means the vertex is 3, 0. The focus for this graph is going to be h comma k plus p. I have h, I have k, I just need to figure out p. So I know that 4p is equal to 16, negative 16 rather. So that means p is negative 4. So that means my focus is going to be h, 3, comma k, 0, plus p, so minus 4. That means the focus is 3, negative 4. The directrix here is y equals k minus p. K was 0, minus p was negative 4. So that's going to be y equals 4. So I'm going to go ahead and graph the vertex, focus, and directrix, and we'll go from there. So now I have my directrix, my vertex, and my focus. Again, I use the focal diameter to find 2 other points to plot on my graph. So if I do negative 16 divided by 2, that gives me negative 8. But again, this is a distance, so I ignore that negative sign. I'm going to go 8 units away from the focus in either direction. And that's going to give me 2 more points to plot. There are my 2 extra points. I'm going to plot from the vertex through this point on the right, from the vertex through this point on the left. Number 4, I have the graph y minus 8 squared equals negative 10 times x plus 7. I can see right away that this is in a y squared form. So this is the standard form y minus k squared equals 4p times x minus h. My k value is going to come from here and my h value from here, which means my vertex is h negative 7, comma k positive 8. The focus for this graph is h plus p, comma k. So I need to figure out p. I know that 4p is equal to negative 10. And I get p is negative 10 over 4, which reduces to negative 5 over 2. Yes, I'm going to have a fraction here. So for my focus, h is negative 7 plus p is negative 5 over 2, comma k is 8. When I add these 2 together, I really have a negative 7 plus a negative 2.5, which gives me negative 9.5. So I'm going to write that as a decimal, actually, negative 9.5, comma 8. The directrix is x equals h minus p. H is negative 7, minus p is minus a negative 5 over 2. So this is going to be negative 7 plus 2.5, which gives me negative 4.5. I'm going to do my best on this small graph to graph the vertex, the focus, and the directrix. Just with these halves, it's going to be a little tricky, so just bear with me. So here is my directrix, vertex, and focus. So I know my graph is going to open to the left. My focal diameter is -10. So if I cut that in half, I get 5, which means I need to go 5 units away from the focus in either direction. 5 units up, I'm not going to be able to reach on this graph, so I'm just going to do 5 units down. And I'm going to graph from the vertex through that point, and then I'm just going to sketch from the vertex going that way. For 5 and 6, we're going to put the equation in standard form and identify the vertex, focus, and directrix. So essentially the same thing that we just did with 1 through 4, just without the graph. So in number 5, I see that I have a y squared. The y squared tells me that I need to get this equation in the form y minus k squared equals 4p times x minus h. I'm going to get everything with a y on the left side of the equation and everything else on the other side. So I'm going to leave the y squared minus 6y. I'm going to add the 36x over, and I'm going to subtract the 117 over. From here, I complete the square for the y so that I can write it in this form. So I have y squared minus 6y plus blank equals 36x minus 117 plus blank. Again, whatever I add to one side, I need to add to the other side to keep my equation balanced. The number that's going in this blank is going to be half of 6 squared. 6 divided by 2 is 3. 3 squared is 9. And I add that same amount to both sides. The left side I can rewrite as y minus 3 squared. The right side becomes 36x minus 108. On that right side, I can now factor out a GCF of 36, and I'm left with x minus 3. Here is my equation in standard form. Now, for the rest of the problem. I know that my vertex is HK. H comes from here, that's going to be positive 3. K comes from here, that's also positive 3. So my vertex is 3, 3. The focus is H plus P, comma K. I need to find P. I haven't found that yet. That comes from the 36. I know that 4P is equal to 36. I divide by 4 on both sides. I get P is 9. So my focus is going to be 3 plus 9, comma 3, which is 12, 3. Lastly, my directrix is x equals h minus p. So that's 3 minus 9, which means the directrix is x equals -6. So again, vertex, focus, directrix. Number 6. I have x squared plus 6x minus 9y equals -81. Since I have an x squared here, I'm going to want to get this one in the form x minus h squared equals 4p times y minus k. I'm first going to get everything with an x on one side of the equation, and I'm going to add the 9y over, so I have 9y minus 81 on the right side. I now need to complete the square for the left side, so I'm going to add my blanks in. Again, this number is going to come from the 6. I half it and square it. 6 divided by 2 is 3. 3 squared is 9. On the left side, I now have x plus 3 squared. And on the right, I have 9y minus 72. I'm now going to factor out a GCF of 9 on the right-hand side. So I have x plus 3 squared equals 9 times y minus 8. My vertex is HK, which in this case is -3, +8. I need to figure out that P value, so I know that 4P is equal to 9, which means P is 9 over 4. The focus is H, comma K plus P, which in this case will be -3, comma 8 plus 9 over 4. So that's going to be -3. Now over here, I know that this is 2 1/4. So 8 plus 2 1/4 is going to be 10 1/4. And I'm going to write it like that. It's just easier to do that than to find a common denominator. Last thing I need to find for number 6 is the directrix. And I know that the directrix is equal to y equals k minus p. K was 8 minus p, so that's minus 9 over 4. So that's 8 minus 2 1/4. So that's y equals 5 3/4. For the next couple of examples, we're going to find an equation for the parabola which fits the given criteria. So in number 7, I need a parabola with a vertex of 3, 0 and a focus of 0, 0. Now, I'm not sure, just looking at these 2 points, exactly which form I need, if I need an x minus h squared or a y minus k squared. So I'm going to do like a mini sketch on the side. If I know the vertex is at 3, 0 and the focus is at 0, 0, I know that my sketch is always directrix, vertex, focus. So if I have the vertex and the focus here, that means my parabola has to be opening this way to the left side. I know that these sideways parabolas are y squared parabolas. So I'm going to have to be able to write this thing as y minus k squared equals 4p times x minus h. From here, I know what h and k are from the vertex. So I know that this is y minus 0 squared equals 4p times x minus 3. So as of now, I've used the vertex piece. I now need to use the focus piece. I know that the focus for a y squared parabola is h plus p comma k. And they told me that the focus was 0, 0. That means that h plus p is equal to 0. All right, h plus p and 0 are in the same spot. I figured out earlier that h was 3, and I'm trying to figure out what p is. So now I can just solve. I subtract the 3 over, I get p is negative 3. I can plug that into my equation here. So I now have y minus 0 squared equals 4 times negative 3 times x minus 3. So now this is y minus 0 squared equals negative 12 times x minus 3. There we go. Number 8, I have a focus of 12, 3 and a directrix of x equals 6. If my directrix is an x equals line, I know that this parabola has to have the form y minus k squared equals 4p times x minus h. They also gave me the focus, which was 12, 3. And I know the focus in a y squared parabola is h plus p comma k. So this is helpful because now I can at least see that k is equal to 3. I can also tell from here that h plus p is equal to 12. Not super helpful, but hopefully the directrix will help fix that. So I know that the directrix is x equals 6, and I know that the directrix in a y squared parabola is h minus p. So I can say that 6 is equal to h minus p. So now I really have like a system of equations thing going on here. If I add the p over, I have 6 plus p is equal to h, and I can plug that in this equation. So this h is going to become a 6 plus p. So that I now have 6 plus p is equal to 12. So that's 6 plus 2p equals 12. 2p equals 6. So p equals 3. That is super helpful. The last thing that I need is h, which I can find from this equation that I had down here. H is equal to 6 plus p. We just figured out that p was 3, so that means h is 9. So there is the 3 pieces of information that I need to fill in my parabola over here. So I have y minus k squared equals 4 times p times x minus h. So if I just do that multiplication, I have y minus 3 squared equals 12 times x minus 9. Number 9, I'm given the vertex, -8, -9, and 2 points on the parabola, so 0, 0, and -16, 0. It's going to be helpful here to sketch this one as well so I have a better idea of what shape this is taking, so I know if I need an x minus h squared or a y minus k squared parabola. So I'm just going to roughly sketch this. So if I have -8, -9 as my vertex, and then 2 points on my parabola are 0, 0, and -16, 0, I can see that this parabola has to open upwards, which means that it's an x minus h squared parabola. So this parabola has to fit the form x minus h squared equals 4p times y minus k. If I plug in h and k from the vertex, I have x plus 8 squared equals 4p times y plus 9. I need to solve for p, but I know that both of these points are points on this parabola. So if I plug these points or these values in for x and y, I'll be able to solve for p. So I'm going to choose 0, 0 because that's just a lot easier than dealing with a 16. So I have 0 plus 8 squared equals 4p times 0 plus 9. So 8 squared is 64 equals 4p times 9. So that's 36p. Divide by 36 on both sides, and you get a gross fraction of 16 over 9. So if I now plug in for p up here, I have x plus 8 squared equals 4 times 16 over 9 times y plus 9. I can clean this up a little bit. So I have x plus 8 squared equals 64 over 9 times y plus 9. Number 10. The equation of a parabola and a tangent line to the parabola are given below. Find the point of tangency. So if I have a parabola and a line tangent to the parabola, that means the tangent line is touching the parabola in one and only one spot. So I can essentially solve this system of equations for x and y to find the point that they're intersecting at. So what I'm going to do is I'm going to use this second equation first, and I'm going to add the y over and subtract the 2 so that I get x is equal to y minus 2. From here, I can plug that into the parabola equation that I had up here. So in y squared minus 8x equal to 0, I can substitute that x with a y minus 2. And now I can solve. So I have y squared minus 8y plus 16 equals 0. That factors to y plus 4, which gives me y equals -4. So I know that they're intersecting at y equals -4. I just now need to find that x value to find the actual point that they're intersecting at. So I can plug in -4 for y minus 2. That gives me -6. So the point of tangency of the parabola and this line is -6, -4. That's it for graphing parabolas. If you guys have any questions, feel free to leave them in the comments below. Have a great day.